We now begin lesson 4.2, part B. I have here in front of you an example that is not in your notes. This is a function of y equals 4 x plus 2 quantity squared minus 3. From this, we know where the parent function that is supposed to be centered over the y-axis with the vertex at 0, 0, that's where it should be, but we know how it is shifted based upon the vertex form equation. X plus 2 means that it moved 2 units to the left. Minus 3 means it moved 3 units down. That means it went 2 units to the left, 3 units down. And this is the new location of the vertex. So which graph would represent that? A has a vertex that moved to the right 2 units, so that's out. B has a vertex that moved to the right 2 units, plus it's going down, and since 4 is positive, it should open up. C shifted 2 units to the left, 3 units down, it opens upward. That looks good. D, this one looks alright, but it went 2 units to the left and went up. That's wrong. So C is our answer. Now, actually, the graph would look like this if the 4 was a 1. But the 4 was, the absolute value of 4 is greater than 1, so it made it narrower. That's why it looks skinnier. Here's another one. This one says that it moved 4 units to the right, opposite of what's in there, and 5 units down. Again, when it's in the absolute value, it's doing the opposite, moving the opposite direction. So the parent function, which should be centered at the origin, with the vertex centered over the y-axis with the vertex at the origin, has shifted 4 units to the right and 5 units down. So which graph looks like that? A, it moved 4 units over, but it went up. B went 1, 2, 3, 4 units to the left. C went 4 units to the left. And D went 4 units to the right, 5 units down. There is the vertex, and it is narrower because of the 4. D is right. One more. This one has a minus 5, which means it moved 5 units to the right. Nothing is here, so it did not shift up or down. So that means the parent function, again, centered at the y-axis, vertex at the origin, has moved 5 units to the right, and that is it. This one moved 5 units down. This one moved 5 units to the right, opens up. This one looks good. This one moved 5 units up, which is not true. And this one moved 5 units to the left. So B is correct. Another one, all right. If you look at this one, nothing is inside parentheses, so it does not move left or right at all. But it did move 2 units down. So it's supposed to be at this origin, but it shifted 2 units down. So it should be here. This one went to the left. Shifted 2 units down, should be here. This one went to the right. This one went 2 units up. Not correct. And D went 2 units down. That is correct. Again, it opens downward because of the negative 2. All right, our last question. Given the function y equals 4 times x plus 5 quantity squared minus 2, find the coordinates of the vertex. Now remember, if it's y equals x squared, it has a vertex at the origin and would look like this. This one has moved 5 units to the left and 2 units down. So 1, 2, 3, 4, 5, 1, 2. This is the new location of the vertex. So our new vertex is negative 5 because it went left 5, negative 2 because it went down 2. So it's actually quite easy to find out where the vertex is located when the function you're starting with is in vertex form. Now, what is the y-intercept? Well, in standard form, y equals ax squared plus bx plus c. The y-intercept was c. And that was pretty easy to tell. But in vertex form, we do not have that ability. So there are 2 ways to find out the y-intercept when it is in vertex form. And that is to plug in 0 for x. That will give us y equals 4 times 0 plus 5 quantity squared minus 2, 4 times 5 squared minus 2, 4 times 25 minus 2, 100 minus 2, 98. I'm sure you could skip some steps there, but that's showing it longhand. So our y-intercept is located at 0, 98. Pretty high. There's another way to do that question, but it would involve this process. Putting it back into standard form, which would be to say x plus 5 squared is the same as x plus 5 times x plus 5 minus 2. We would FOIL and work its way back into standard form. This is quite a few more steps, and we'll get to this at another time. But for right now, plugging 0 in is a much easier process. Here concludes Part B of Lesson 4-2.